Hi, I'm Tara Lee, Product Manager for Lab Automation at Benchling. And today I'll be talking about how you can harness the full potential of your laboratory hardware with Benchling for Lab Automation. I'll talk both about what Benchling is, the drivers behind why we built our lab automation product, as well as how our lab automation product was able to support COVID testing workflows across the world. Founded in 2012, Benchling is a widely adopted life sciences R&D cloud designed to give a 360-degree view of R&D innovation. From a single interface, Benchling supports a wide range of R&D processes with applications that span the entire workflow, from design to experimentation to sample traceability and analysis. We take time to understand our client's science and recommend the most appropriate data model that captures every step of their process and products, from DNA constructs and vectors to cell lines and proteins to reagents and animal models. These applications are all interconnected with one another as well. For example, the plasmids made in the molecular biology suite can be registered in the registry, which can then be requested via requests. These applications all operate on a highly configurable unified data layer to ensure full traceability, providing the ability for rich querying and analysis. And our platform provides extensibility to connect to instruments, other applications, and data stores, so Benchling can integrate with the existing ecosystem. We provide REST APIs to easily move data in and out of the platform. The life sciences industry has evolved tremendously over the past decade, and we're proud to work with hundreds of leading companies that have helped develop new advances in biopharma, agriculture, and industrial biotech, a few of which are displayed here. Throughout these industries, lab automation has become a critical component of the research and development workflow. The emergence of new complex drug modalities has led to orders of magnitude of increase in throughput requirements in order to improve the probability of success and support the scale of research. An increased competition for market entry has led to greater investments in efficiency via instrumentation and robotics in order to accelerate the pace of research. However, despite this, companies are still unable to maximize the benefits from their automation investments. The informatics side of automation remains disconnected from hardware, with many traditional LIMS systems too rigid and hard-coded to support the throughput and complexity of automation. For example, in some systems, once the workflow has been configured, it can be nearly impossible to change the configuration to adapt to new requirements that are coming in. These bottlenecks for data aggregation and sample traceability ultimately impede the pace of research. We need a system that can both handle the throughput and remain flexible for the changes that often occur in a research workflow. And so, given this disconnect, we built Benchling for Lab Automation to bridge the gap between informatics and hardware. Given that Benchling is already supporting the next generation of life sciences research, and that R&D is investing more and more in automation, we built Benchling for Lab Automation to seamlessly integrate Benchling's core product with instrumentation. It allows scientists to easily keep track of the results and actions performed on liquid handlers and analytical instruments, and we'll discuss a few examples in this presentation today, along with a demo of the product as well. So how does Benchling for Lab Automation work? Benchling's suite of applications, as mentioned, includes the registry and inventory. Within Benchling, Scientists can keep track of their scientific entities like their cell lines, reagents, plasmids, proteins, and more. They can put these scientific entities into inventory items like containers, plates, freezers, fridges, or shelves. Where lab automation fits in is that with Benchling for lab automation, users can then generate input files based on the items in the registry and inventory, and also ingest and parse output files coming from the instrument of interest. We built this to be instrument agnostic with flexibility to support a variety of use cases, all with codeless configuration. We partnered with leading biopharma and industrial biotechs to support their use cases, such as hybridoma screening, enzyme development, and NGS. And so we released Benchling for lab automation in January 2020. But soon after we released it, the COVID-19 pandemic changed everything. We began to see our customers invest in COVID testing capabilities, and we quickly realized this product could be used to power testing at scale. Two of the companies we supported in their COVID testing efforts were Corteva Agrisciences and DTU, the Technical University of Denmark. I now want to highlight 4 of the key capabilities of Benchling for lab automation that enabled these teams to get testing off the ground in a matter of weeks. These being Benchling's native ability to track complex relationships, our intuitive approach to automation, the platform's rich API extensibility, and our highly iterative configuration that adapts in real time. When dealing with patients, derivative samples, and COVID diagnostic results, the legacy way of working isn't going to work. Handwritten notes and versions upon versions of CSVs or Excel sheets go from being inefficient to being impossible with high throughput. Increasing scale and turnaround time means that you need expert data management to easily store, retrieve, and make sense of all of the data that's coming in. Benchling for lab automation is centered around our core relationship model. So we build your workflow so that we can track the end-to-end lineage of everything that's being produced. In this example, tracking the lineage from patient to sample through PCR intermediates to the final results. This means that you can always track samples back to the patient, and you can count on our registry's data validation to make sure that registered entities are not being duplicated or that they have all of the required fields filled out. And this is all set up in a point-and-click interface, and it's highly iterative and can be done in as little as a few minutes as well. When we increase scale, these relationships only become more important. COVID testing teams need to make sure that they can keep track of samples as they're stamping dozens of plates of extracted patient samples to larger format plates with reagents to perform PCR. Benchling for lab automation natively creates these links during plate operations so that the lineage and chain of custody are all recorded. All of the intermediates are captured to track the actions taken, and everything points back to the patient and sample. And setting this up, again, doesn't require any time or effort. It's a core part of our product. Scientists also interface with automation from Benchling's laboratory notebook, and this creates an intuitive flow between the manual and automated actions in the workflow so that scientists can start processing samples with minimal training. Data ingestion after the run can be entirely automated to ensure data capture is timely and accurate by removing the need for scientist action. Benchling for lab automation is also built on our fully extensible platform with a logical integration architecture. Corteva, for example, was able to quickly connect to providers, instruments, and existing software to get their testing workflow up and running in a matter of weeks, integrating these key data sources and allowing our out-of-the-box functionality to handle the rest. Additionally, during this COVID testing workflow, many changes to the testing protocols occurred over the course of the spring and summer. And because Benchling for lab automation is highly configurable without any code, we can, for example, change our PCR technique from using 96 well plates to 384 well plates to increase throughput in a matter of minutes, enabling teams to keep up in real time. This also extends to if the instrument needs a new type of input file, we can easily adapt the input file generator to generate that new type of input file as well. Now I'll do a demo of Benchling for lab automation using an example COVID testing workflow. In this demo, I'll be showing how Benchling can generate an input file for a liquid handler that takes an extracted sample plate and combines it with forward and reverse PCR primer plates to create a plate of the PCR product. From there, we can upload an output file from the theoretical liquid handler to update Benchling to reflect these transfers in the new PCR products. And then we can record the results on the PCR product plate. So now I'm in the Benchling system and I've opened up my Benchling entry where I'm going to be demoing the COVID testing lab automation run. This run is, like, as I mentioned, going to generate the input file that's going to combine the extracted sample plates with the forward and reverse primer plates. And it's going to create these PCR products into my empty PCR plates. I'm also going to be able to enter in what volume I want to take out from my extracted sample plates, and I can include that in my input file as well. And so let me now fill in the plates that we're going to use. So I can search for the different plates that have already been created that I'll be using to create this run. As I fill out these different plates, we'll see that they turn into links that once I click create, I'll be able to click onto them and see exactly what's inside as well. So now I'll click create. And first, before I actually hit generate and generate the input file, I wanted to first show you what these plates actually look like in Benchling. So if I click on this extracted sample plate, you'll see that it's going to load up my sample plate and it's going to show me the contents in each of the wells. Here I just have example randomized sample numbers, and they each have a volume of 100 microliters in each of these wells. Similarly, I can also check and take a look at what's in my forward primer plate, and you'll see that it's the same forward primer in each of the wells of this plate. So what I can go ahead and do now is click generate to generate my input file. And what it's doing is it's taking the information that I entered into the fields above, looking up the relevant information and creating a CSV that will map all of the actions that a liquid handler would need to perform. So if I open up my CSV, I can share what that looks like. You can see here that the CSV took the information in the plates, the sample plate barcode coordinates, and also filled out all of the information from the forward and reverse primer plates, plate coordinates, and indicated which destination plate the instrument should put all of the samples and primers into. It also indicated the transfer volume as looked up by the value that I filled out in the run earlier. And so what you can do now is take this file and give it to a liquid handler, either through one of the out-of-the-box integrations that I mentioned before, or manually uploading it into the liquid handler. And we can assume that the liquid handler is reading each of these rows and performing the appropriate actions based on the barcodes and coordinates listed here. And so now going back into my entry, from there, let's assume that the instrument finished the run, and it provided an output file that looked very similar to the input file. And now we want to say that in Benchling, it performed all those actions and it created those new PCR products. So first, very quickly, if I click on this plate, we can see that it's empty. There's nothing inside of it. This is the destination plate where we want our new PCR products to be created. And so if I upload that output file, what will happen is that once I click process, it's going to process the file in the exact way that is configured, and we can create those new PCR products into that plate. So I'm going to drag the, again, theoretical output file into the system. And now I can hit process. And so what's happening in the background is that Benchling is creating a new PCR product for every single row in that file and creating it in the empty destination plate specified. So now if I click onto this plate, I can see that before, while it was empty before, now it's been filled with the PCR products. And if I actually click on this link, I can see exactly which sample this PCR product was created from, and the forward and reverse primers that were used on the sample. So from here, with the test results, I can also now upload test results on those PCR products and upload it directly here. So what I'll do is I'll bring up I'll upload a file that has test results in it, and very quickly I will first actually share what that file looks like. So here's the example file that I'm going to be uploading into Benchling. We can see that it only has the plate ID and the well coordinate, and then it will say what the result and action of the COVID test is. So going back to the entry, I'm going to find that file and upload it into the system. And once I hit process, what it's going to do is it's going to find the samples and process the test results that are associated with the samples in those plate and well coordinates. And so now if I take a look, I can see that it found the sample in that plate and position, and is giving me the result and action that correspond in that file. And so that's the demo that I wanted to share. But very quickly, I also wanted to kind of show how easily configurable the system is as well. So first, with the registry, the PCR product, the samples, and the primers, those are all configured as schemas in Benchling's registry. And in this tab, we can see how easy it is to modify the schema as needed, changing things like the prefix or the schema name, adding fields, and linking to the different types of entities that it needs to link to. And so if I can easily click on the sample that it links to and see all of the information on the sample schema there, and I can modify those linkages if I would like. On the run schema, the run itself, so this box and how we configured this box to have these fields, generate the input file in this way, and process the output files this way, is also highly configurable. In the run fields, I can specify exactly what fields will show up in the order of them. And here is where I can configure the input file and say exactly what columns I want in the input file and how to look up the information that's going to be filled out in the rows for each of those columns. And so ultimately, why choose Benchling for lab automation? First, we are unified with the other powerful applications in Benchling to allow data capture to be uploaded into the notebook and integrated with all relevant Benchling applications. We also have rich sample and process intelligence to powerfully link samples to other relevant items in the registry. And lastly, Benchling for lab automation is flexible and has codeless configuration. The integrations between informatics and hardware are not hard-coded, and they can be easily modified to support new processes in a matter of minutes. Thank you so much. To learn more information, please contact our biotech research enablement representative, Lauren Cossey, at lcossey@benchling.com. And thank you for attending.